So in this video we'll start to prove a lemma and a corollary from that lemma in order to prove in a later video the Chevalley-Warning Theorem, which is important for projective space over finite fields. So let's start. So let's take an integer I, which is between 1 and q minus 1, and the lemma states that if we sum over all elements of a finite field, so q is, let's say, p to the n, and then this sum is equal to 0. Okay, and p of course is a prime. So let's prove this. So the map where x gets mapped to x to the I, so this integer, this is a homomorphism, or let's say endomorphism, is an endomorphism of fq star, so of the non-zero or invertible elements of the finite field. And so especially it's a character. So just to give you a short reminder what a character is, so it's a character of this group, and a character in general is a group homomorphism from a group G to the invertible elements of a field, and chi is a group homomorphism. And we call it non-trivial if it's not the map that sends everything to 1, because that's also a group homomorphism, but that's the trivial one. And now what I claim is that this map x maps to x to the I is not just a character, but is a non-trivial character. So why is that? That's because the invertible elements of a finite field, or in more generality, any finite subgroup of the multiplicative group of a field is cyclic. So also this group is cyclic, this multiplicative group, and so there exists an element of order q minus 1. So this means that for this element, let's say x to the I is definitely not equal to 1. Okay, and now there's a general fact about characters, namely that the sum over the characters of the group is 0 if the character is non-trivial. So we use this, then what do we get? So the sum over x to the I is the same as if we sum just over the multiplicative group. And now we use the fact about characters, so this gives us that it's equal to 0. And you can also try to prove this fact about characters as an exercise, or you can also look it up. I think one can find this. It's a well-known fact. Okay, so that's for the proof of this lemma. And now let's derive a corollary from it. So let's take an m tuple E1 to EM, and let's maybe, so these are all integer entries, and or rather should be, I guess, non-negative. So, and furthermore, we want that the sum of these ej's is less than q minus 1. Okay, and now the statement is that if we sum now over all elements in, not the field fq to the m, but the vector space fq to the m, then x to the e, where x to the e is defined as just x1 to the e1 up to xm to the em, this is 0. Okay, and this now follows just from the previous lemma, so let's write it out. So we can write this sum as m sums, so x1 in fq up to xm in fq, x1 to the e1, xm to the em, and we can also write it as a product of these sums, so x1 in fq, x1 to the e1, let's say xm in fq, xm to the em, and now by assumption we have this assumption, so we know there exists a j which is in the set of integers from 1 to m such that ej is less than q minus 1. Okay, but if ej is less than q minus 1, then we get that this sum is in fact equal to 0, and so the sum corresponding to ej, so this whole thing is 0. And now let's maybe one more remark. So there's a small subtlety here. So we can either say extend this result here for I equal to 0 if we say 0 to the 0 is equal to 1, then it also holds for I equal to 0. And then we can also apply it here for non-negative integers. So even if ej would be equal to 0, or we have to restrict ourselves here if we don't want to make this definition to the case where these are not just non-negative, but in fact positive. But yeah, let's just stick with this definition, so we can replace 1 by 0 here, and then we get our corollary. Okay, so that's it for today. Next time we'll see a little bit more about the Chevalley-Warning Theorem, and yeah, I hope to see you then. Bye.